In all languages, alphabets combine to give words and words combine to give sentences. Similarly, in the language of chemistry, the chemical symbols combine to give the chemical formulae. Now what happens when these chemical formulae combine? Let's see. A lot of chemical reactions take place around us every day. Like cooking of food, it's a chemical reaction. Burning candle, it's a chemical reaction. Now, if you see a chemical reaction taking place, how do you represent it on paper? Say, you must have seen burning of coal. Now what's happening here is, we have coal, it burns in the presence of oxygen and carbon dioxide gas is released. So this is what is happening when you see burning of coal. So how do you represent it on paper? You say that coal, it's nothing but carbon. So coal reacts with oxygen to form carbon dioxide gas. Now in terms of chemistry, we represent it like this. So the symbol for coal or carbon is capital C. Symbol for oxygen is O. So two oxygen atoms combine to form oxygen molecule. And when they react, they release the carbon dioxide gas. So a combination of the formulae gives us the chemical equation. So in the language of chemistry, when the chemical formulae combine, they give the chemical equation. So the chemical symbols combine to give the chemical formulae, and these chemical formulae combine to give the chemical equations. So for any reaction that takes place, we have the reactants written on the left hand side. So coal or carbon reacts with oxygen. So that's shown by a positive sign. The substances on the left hand side which take part in the reaction are known as reactants. The substances that are formed as a result of the chemical reaction are known as products. They are written on the right hand side of the arrow. So we have the reactants shown by a positive sign, the number of reactants. They give the product. So there can be more than one products being formed. So in this case, carbon and oxygen are the reactants. They react to release the carbon dioxide gas, which is the product. So let's say we have this kind of a reaction taking place. Here we heat copper carbonate, CuCO3. This is being heated. A substance copper oxide is formed and a gas carbon dioxide is released. So how do we represent it? We have CuCO3. So there's only one reactant taking place in the reaction. So we have CuCO3. It's being heated. So whenever an external condition is given to the reactant, that is shown on top of the arrow. So we show that the reactant is being heated by this heat which is written. Another symbol for heat is a delta sign. So if heat is not written and only this sign is shown, this also means that the reactants are being heated. So in this case, CuCO3 is heated to form copper oxide and to release carbon dioxide gas. So we have one reactant and two products. So in any chemical reaction, we have different forms. So we can have one reactant, so calcium carbonate, it forms calcium oxide and carbon dioxide. So one reactant and two or more products. We can have two reactants reacting to give one product, like carbon reacting with oxygen to give carbon dioxide gas. Or we may have two reactants reacting to give two products. Similarly, we can have any number of reactants reacting to give any number of products. The number of reactants and products is not fixed. So sometimes you will see symbols like this in a chemical reaction. What do they represent? We have a chemical equation, so where A reacts with B to form CDE. Now we have the subscript S. This shows that A is in the solid state when it takes part in the chemical reaction. When we have small l or small aq written, this shows that the substance B is in the liquid or aqueous state. In this state, it takes part in the chemical reaction. Similarly, if a subscript G is used, this shows that C is being formed in the gaseous state. So a gas C is formed. A downward facing arrow. This shows that something is left, something remains behind. So this shows that a residue or precipitate is being formed. And when you see an upward facing arrow, this means that something is escaping out. So that means a gas is being evolved. So if you see signs like this in a chemical equation, they show the states in which these reactants and products are. So we know that when heat, an external condition, is being provided to the reactants, it's written on top of the arrow. So A and B react, that is they are heated to give C and D. When heat is written on the product side, this means that A and B, they react to form C and D, and also heat is released. So this time heat is a product. But when you see something written like this, this means that A and B react only when they are heated. So heat is also a reactant in this case, since heat has to be given for the reaction, and it forms C, D, and also heat is released. This means heat is also a product. So heat is both a reactant and a product. It's only when the heat released is more than the heat that we are giving to the reactants that it is released, and we write it on the product side. So heat can be both a reactant, a product, and it can be present as both in one reaction itself. Now this is a chemical equation. What is the number of reactants and products which are taking part here? So do not get confused by these numbers that you see. We know reactants are the substances taking part in a reaction. So we have 1, 2, and 3 reactants. Products are the substances that are formed as a result of the chemical reaction taking place. So we have 1, 2, 3, 4. So we have 4 products formed. So do not confuse with these letters. So these are different substances. The number of different substances that are formed is 1, 2, 3, 4. So we have 3 reactants taking part to form 4 products. So like all languages, they have the basic structure, alphabets combined to give words, and the words combined to give sentences. Similarly, in the language of chemistry, the chemical symbols combine to give the chemical formulae, and these chemical formulae combine to give the chemical equations.